In this class, we are going to understand data types in C in quite detail. I have interacted many of students and working professionals. When they have to choose some data type, they invariably tend to focus on either an integer for a lot of programming variables or, depending on the situation, some other data types. However, we have to really give a good focus on data types and what particular type a variable must have. So to begin this class, I want you to focus on three different distinct tests. It's a quiz kind of a test. So please have a pen and paper ready. What we will do is we will try to understand some of these important questions in terms of understanding data types. And then I will elaborate more about what are the data types in C programming, as well as the solution for some of these tests that I have written here. So first question, which data type is most suitable to store the size of a hard disk partition? So 10 gigabyte partition size. Number one, integer, unsigned integer, long, unsigned long. So please go ahead and then write in a piece of paper answer for test 1. So here's the answer. Answer is D. Let's go to the second one. Which data type is most suitable to store the data of a 8-bit microprocessor or microcontroller? Char or character, unsigned character, integer, unsigned integer. Again, pause for 2 seconds. Note down your answer in a piece of paper. Okay, so the answer is B, unsigned character. Let's move on to the third one. Which data type is most suitable to store the length of a string? C, string length function is just an example. Integer, unsigned integer, long, unsigned long. So the answer is unsigned long. So these are the three test questions that I have created for us to think deeply about the choice of data types for our programming variables. If you got all three of them right, then I am sure that you understand what you are really doing. I have seen many people, they don't have considerations for it, right? So I am going to explain in quite detail. So I am also going to explain the reasons behind why the answers are for all the three questions with some good real life examples also. Okay, so please continue to watch this video. This is just an introduction to our data types in C programming language. Okay, we are now going to introduce it. Once I introduce the data types and primitive data types, right, then I am going to come back to this three test questions, and I am going to explain in detail the answer, why the answer is what is written there actually. Okay, plus some examples, plus some real life examples I will also depict for these three examples. So what's a data type definition? Data type is the information generally about the type of data you store in a particular memory address. See, in C programming and in general any programming language, we need to store some programming variables, right? Variable can be a 1-byte variable, it can be a 2-byte variable, 4-byte, random number of bytes, collection of lot of variables by some named object, right? So we have to remember that in C programming we have to store the data. When we store the data in memory, now we need to assign a programming construct for that. Is that memory represents just a sequence of character, or is that memory represent a byte, or does it represent an integer, right? Or does that memory represent a floating point data type, right? So we store the data in memory and then we must assign a type, right? So think about integer. We generally use integer x. So integer mostly on 32-bit systems, definitely in 32-bit systems and 64-bit systems, integer is 4 byte. What about a float data type? Float, yeah, float is also 4 bytes. So now there's a piece of memory where you are storing either an integer or a float. So there is 4 bytes allocated, right? So it's a piece of memory. Now you must attribute a programming construct in terms of data type for that. And that is what is data type is about, the type of data which is stored in a particular memory location. Now, since this is an advanced course, my understanding is you will be knowing some of the basic C related constructs, C data types, and everything about C in a simple fundamental level, right? So we'll quickly skim over and try to understand different types of data types, which is given by C programming language. So you have a primitive data type, you have a user-defined data type, and then you have a derived or dependent data type. So this is one kind of classification you can assume for C programming language. Let's go deep into each of these. Primitive data types, right? So if you study Cunningham and Ritchie, the best book, right? So the best book on C, Cunningham K and R. He has introduced the concept of primitive data types, and it's a very nicely designed, constructs. When we think about programming in general, we need to allocate a piece of memory to store some data. Okay, so when you see character, right? So when you're talking about character data type, what is coming to our mind? We really need a piece of memory to store 1 byte of information. Okay. So the way it has been designed is we require a data type to store 1 byte of information, or short. Short is all of you know is a 2 byte of information. Integer 4 byte, long again 4 byte or maybe an 8 byte, and then you have a floating point, real numbers, and then double 4 byte and 8 byte, and then void. So let's cover each one of these in some more detail actually, right? So when you talk about character data type, the focus here is we require a construct. We require some support from programming language to declare and define one storage space for 1 byte and store the data. Many of you know character generally means the symbols, right? So we have ASCII table, so all the symbols are represented in an ASCII table, and you have an ASCII value for it, right? Unsigned 8, you have a U8 we call it. So you will have 1 byte of representation. Character is just 1 byte representation. It does not mean that it's a character always, like A, B, C, D, whatever symbols you see in your keyboards. Okay, character can have a value, because ultimately in the memory, what do we store? We store bits. So think about a byte, we have 8 bits of information. That 8 bits of information can be always written in terms of some character. For example, capital letter A, the keystroke capital letter A. So we define a programming construct or a variable char C or character C equal to A in quotes, single quotes. Are we storing A in the memory? The answer is absolutely no. We are not storing that A in the memory. So what do we store? It gets converted into the equivalent ASCII value or the so-called decimal value, right? So A is 65, capital A is 65. So in memory, we are storing 65. And what is 65 in binary? 65 in binary is 01000001, right? Okay. So yeah, you can definitely write it in terms of binary, and that's what gets stored. So ultimately in memory, whether you have any of these programming constructs, right? Any of these variables, in memory, we are always going to store in terms of bytes and internally in terms of bits. Okay. So I repeat, character is definitely a character, and but the way it is stored is in terms of bits and bytes. So it's basically a number. Now we had a requirement in the grand old days when we had the C programming language. So programming language was done almost around 1970s, right? So we are close to 50 years that programming language has been created, right? At that time, we rarely had 32 bits 64-bit operating environments. We did have, but yeah. So at that time, there was a requirement to store an integer value, right? So we wanted to have programming construct for an integer value. And then when you say integer value, we'll have a lot of 16-bit processors or 16-bit microprocessors or processors, okay? And then they said you want to store that data. So they created a type known as short. It is short, or people call it short integer. I repeat, it is short or short integer, right? Both are same. That is going to store 2 bytes of information. And then we had an integer, which is the fundamental in C, right? So everything is assumed, any integral value by default is assumed to be an integer in C programming, right? So integer was for 4 bytes storage. So you wanted a much bigger number to store, so it can go up to 4 bytes of data, right? So 4 bytes is like 32 bits actually. So integer stores a 32-bit number. And then we had situations, we had a 32-bit processor for quite a long time, and then eventually we came out with also 64-bit, right? So when you talk about integer and long, you might have read that, they are pretty much same. Yeah, in terms of storing a value which is an integral value, right, it's always same. So short, int and long, all three of them store integral value. But why the long is there? Long is there because you wanted to store a long integer, right? So when you read K&R, Cunningham-Ritchie book, so you will have the references for short data type or short int or an int or long int, right? So short integer and an integer and a long integer. They basically represents what is the range of value that you can store for each one of them in your programming environment. So long on a 32-bit environment obviously will be a 4-byte entity, and then on a 64-bit environment, because now the fundamental environment is 64, so we are talking about 64 bits or a 8-byte entity. So we had 3 different classifications in terms of primitive types for storing an integer value. And then so as part of programming language, we did not want to restrict ourselves to just these 3 in terms of integer, because we do a lot of computations and calculations where you have real numbers, you have fractional values 1.2, 1.5, 2.5, right, or 2.12, 13, 14. So there was a requirement to store real numbers. So we have floating point. So floating point is just for real numbers where you have a lot of fractional values, right? So float data type was created to store 4 bytes of information. And then we have double. Now double is a special situation in the earlier days because you wanted to store much more higher precision, right? So if you have 1.1, 2, 3, 4, 5, 6, 7, 8, 9, right? So you have a very long, more data after the decimal dot, right? So how do you store? So float was created where it can store up to 6 digits of precision. So after that decimal, so 1, 2, 3, 4, 5, 6. So those 6 decimals it can store, 6 positions, right? So 6 digits of precision. And double was created to store 10 digits of precision. So after the dot, you can have around 10 digits, that it can store. Now we require different memory representations, right? We require different memory allocations for them. So it is a 4-byte, and this is very high precision, right? Basically. So double was, 8-byte entity. So even in the world of 32-bit processors, which was there for quite a long time in the Intel series actually, okay. So we had double as an 8-byte, right? So the next one in terms of primitive is like a void data type, okay. And this is where I see a lot of people get confused, okay. Void data type in really is not a data type, because void means nothing, right? So you cannot say void X. So you are telling the compiler that please allocate me X, and it is a void, which means it is nothing. So no space for it, correct? So void was created as a special situations for a lot of programming situations, where we want to return the data type of a function, correct? Sometimes we also do, one is the data type of the function. So sometimes we don't know what function does. So function does nothing. Sorry, function returns nothing. Function will do a job, but it returns nothing. Right? And we have a lot of classical examples for that. Okay. void was also, so this is one example in terms of void understanding. Okay, another one is void was created because many a times, the functions will do a job, and then they want to return something to the caller, the function which have called them, right? So those functions, for example, the most popular one is malloc, right? So malloc is going to return a piece of memory. Now, what is the usage of the piece of memory? Are you going to store? Are you going to return just a piece of memory, and it is going to do any integer work on that, or some structure work, or some character work, right? So we don't know that memory is for what purpose. So ultimately, you are going to get. So what does malloc return? Malloc returns a pointer. It gives you a pointer. But pointer of what data type? Yeah, so that's the problem, right? So because the caller wants to allocate a memory to store characters, or the caller wants to store, he wants a piece of memory to store integers, right? Or to store an array of structures, right? So in those situations, it is very difficult for the function to return a particular return value. So those things are basically void. So this returning a pointer to a void. So when you really see it, it's a pointer to a void. So what you eventually will see, if I have to do a man page on that, right? So when you say man malloc, when do a man malloc, what do you get? You're going to get a malloc, right? You can see the malloc man page here, this particular line, and what does it return? It returns a pointer to a void, right? So I think this is important to know. Many times in programming situations, the function does not know what is the purpose of the piece of memory which I am giving, or what is the exactly the purpose, right? Some sort of a pointer, but we don't know who is going to use in which way, which data type, right? So ultimately what we do is, whenever we do any programming situations, it has been a best practice and mandatory to do a malloc, and then generally for a lot of these functions which returns a void pointer, we must typecast it. So as a grand rule of programming, right? As a grand rule of programming, what you will see here is, you will see that whenever we have a say character pointer p, we always do a char. So we do a typecast to the malloc, because malloc is returning a void pointer, right? So we say malloc, and suppose you are interested to allocate a 50 bytes. So the 50 bytes, and which will be consumed by a character pointer, right? So you typecast. So the idea is, whatever is the data type here, what is the data type for p? It's a char p, character pointer. So you must typecast it, so that at least the lint checker gets satisfied. Okay, but this is not for lint, this is for our own programming knowledge. What is the purpose of this memory? So typecasting, right? And that's the reason, because when you look once again into the man page of malloc, what does it say? It simply says that I am a white pointer, right? So I am a white pointer. I will cover in lot more detail in my class on dynamic memory allocations and malloc. I'll go completely in and out in that. Okay, but let's come back into the class in terms of understanding our meaning of void. I hope you got the data about void now. Let's move on into something more. Okay, so and this is very interesting and very important. So when you have integral values, like you see short, int, long, as well as char. Okay, remember char is just a representation for us in terms of some keyboard symbols like character A, B, C, D, and all of them. But internally in memory, it's just a memory location. It's an integer value. Okay, I will talk about it more. I will talk about it more in terms of type conversions. Okay, so if you have integer values, or if you have real numbers, right? These guys basically, right? As well as character, which is same as integral values now. You have to think about signed or unsigned, okay? And this is very, very important. And that's where, I have given you some 3 different examples at the beginning of this video, right? We'll discuss about it. So yeah, when you define a programming variable, you have to also tell, whether that memory location where you're creating, right? Whether it's a signed or an unsigned entity, right? Okay, we'll cover more. Now, let's come back and understand why the answer is what it is. Okay, so the first question was the first question, which data type is most suitable to store the size of a hard disk partition? And I have given an example of 10 GB, right? It's a 10 gig. We are talking about 10 gig partition. Is it more or is it less? Generally, as on 2021, when I'm doing this recording, right? The size of the hard disk that we today buy out of the box in any of these laptops are 500 gigs, 1 terabyte. Okay, and even if you have SSDs, you are 500 gigs, 250 gigs, and sometimes if you have budget, you have 1 terabyte. So yeah, this is a very simple question that way, right? So let's look and try to understand. And what's the answer? We have chosen these 4 values, and then the answer will invariably be something which I think all of you will know. I will deliberate more on this answer. I'll explain why the answer is the way you are seeing it here right now. Okay, so let's go into some scratchpad to do some computations. First thing first, I gave an example of 10 gig of storage, right? So basically what we are talking about, a hard disk partition, right? It's a partition. Now partition was just an example. So let's cover a little bit more detail about data types now. Okay, so when you talk about the choices, what was the choice? We have integer, and then we had long, and we say unsigned int, and then we had unsigned long. Okay, this 4 of them. So the fundamental question is, I've seen a lot of people in programming, they will blindly say integer, and they will define a programming variable, size of disk. That's the programming variable, right? And then they will say size of disk equals to say 10 gig, right? So 10 gig, I am just now becoming more programming oriented, because 10 gig is not, we cannot write like this. So we have to write into, what is 1 gig? 1024 kilobyte. So let's break it further, right? Basically, especially in programming for C, primarily when you are doing fundamental programming, a knowledge of kilobyte, megabyte, gigabyte, all those numbers should be crystal clear. Okay, so when you think about this, if I have to elaborate it further, what we are looking at is that's a gig. So what is 1 gig? When you say 1 gig, we are looking at 1024, 1024, 1024. So this is what? This is 1 kilobyte, right? So I think, I'm sure readers are aware that 1 kilobyte equals to 1024, and then 1 megabyte equals to 1024 kilobyte, and then 1 gig equals to 1024 MB, right? Now I remember this is scratchpad, right? So this is not a really C code I am writing, because I cannot write like this. This is just an explanation, right? So remember, whatever I write in a scratchpad, most of the times it is just an explanation. Don't take it like C code. Yeah, even though this is a C code, okay? But please don't take it like that. All right, so when you look into this now, we are essentially a 10 gig entity, right? So quickly, how many bytes of data, how many bytes of storage is needed to store this? That is the fundamental question. So can we store in an integer or not is the question now. Okay, so let's look into what is the maximum value that you can store in an integer, right? So let me repeat, the fundamental question here is, what's the maximum value that we can store in an integer, right? So integer, what is the total byte allocated for an integer? Integer is basically 4 bytes, right? So when you say integer, we are talking about 4 bytes. 4 bytes means how many bits? Is 32 bits, right? Because 1 byte is 8 bits, so 4 bytes is 32 bits. Now in terms of storing the values, the minimum that we can store, or the maximum that we can store, is what we should arrive at. Okay, so in reality 32 bits we can store. What's the highest value? 2 raised to the power 32, and then minus 1, because that's the range, right? So think like this. So we can store the highest value when all the bit positions on this 32 bit is 1, right? When you talk about binary numbers. So we are talking about 1111, sorry. Yeah, 1, 2, 3, 4. So this is 1 byte. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right? Now this is what I have written. So when all of these are 1, so this is 1 byte. This is another one. This is another byte. This is another byte. So that's where we have 32. So I'm sorry about that. This is this is byte, 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 byte. So totally we have 4 bytes and then 32 bits. So when you have 32 bits, what's the maximum value you can store? This is the value, 2 to the power 32 minus 1. Okay, so this is the real value. Now a question comes to our mind when you do this. Two ways to look at it. Okay, one is this is this, if you see this one, this is like a most significant bit, and this may be like least significant bit on a little endian system. Okay, so if you improve it further, this is like LSB, least significant bit, right? And then this guy, when you look into this, this is MSB, right? So this is MSB. So this is most significant bit, isn't it? Now a lot of people will say, yeah, but we know in programming the most significant bit is the sign bit, so we cannot have such a large value. Okay, we cannot have. Absolutely right, actually. So think about a programming situation now. Can a size of disk, so what was the original choice? The choice was size of a disk. Can it be a positive number or a negative number? So can size of a disk be negative number? Answer is no. It can be 0 or it can be more than that. So I have seen so many programmers, they just blindly write like this. Okay, so this is not correct. Ideally speaking, it should be, now we all are in the same page, it should be some unsigned, right? So first thing is it should be unsigned. So it's an unsigned entity. Now since we broke it down like this, and the programmers know that this is an MSB, right? Okay, now since we are an unsigned entity, we pretty much know that this is not a sign for a unsigned entity. So MSB represents a value. So now our hypothesis or assumption is correct. So 2 raised to the power 32 minus 1. Okay, that's the value. Now let's break it further. What was our assignment? Hard disk partition size 10 gigs. So let's see what is the maximum value of this particular number. For the sake of calculation, I will just assume it to be 2 to the power 32. We'll ignore minus 1 for the sake of calculation. Okay, so let's come back here into the calculation. So what's 2 to the power 32, right? That's where I am at. 2 to the power 32 equals 2 to the power 2 into 2 to the power 30, and 2 to the power 30, as you know, can be broken down. So this can be broken down further. So 2 to the power 2 and 2 to the power 30. So this is 4. 2 to the power 2, right? It is 4 into, now 2 to the power 10 into 2 to the power 10, and then 2 to the power 10, 3 times, right? So when you see this 3 times, so this is 2 to the power 10. Some of the readers who are more advanced, they understand 2 to the power 10 is exactly 1024. It is 1 kilobyte, right? So this is 1 kilobyte. This is 1 kilobyte, 1 kilobyte. So what we are essentially ending into now, right? We are now into a position where we can easily say that it is 4 kilobyte, 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 right? So when we say it is 4 kilobyte into kilobyte into kilobyte, isn't it? So what the answer? The answer, when you see here, is 4 kilo into kilo meg, and this is gig. So we are essentially looking at this number. Okay, so it's a 4 gig. So the short answer or the long answer eventually, or the long version, right? So we have looked into now is the final answer, 4 gig. So this number is 4 gig. So what was our original assignment? So original assignment was we wanted to have a data type where we can store this value. So this value was 10 gig is a partition, and we have 4 gig here. So if you declare an integer, if you declare an unsigned integer here, then we will never be happy, because unsigned integer can store up to 4 gig and then -1, right? Okay, so this is the value. So we cannot choose unsigned int. So unsigned int is not the correct answer. This is not correct, not at all, right? So this is not a correct answer. So what do we choose? So the choice there we have is basically now, the last one. So we require one more higher data type, as you know, basically. Okay, so you will have, just hold on, yeah. So you will have the next choice that we are giving here, right, basically is unsigned. Yeah, so we'll have an unsigned long. Unsigned long, because long is the next higher data type after integer, right? So this is the correct answer. What is long? Long will contain 8 bytes of data. 8 bytes is a very large number, 2 to the power 64 minus 1 if you do an unsigned, actually. Okay, so this is the answer for that question, where we wanted to make sure that what's the answer. I'm sure you understood the explanation, right? So we have to have a careful focus about choice of data type for our programming. Let's move on to the next one now, right? So which data type is most suitable to store the data of a 8-bit microprocessor or a microcontroller, right? So this is a very interesting question, because when we do embedded programming, when you interface in the kernel with the device drivers, when you interface in the kernel with registers, right? So anywhere you have an interaction with hardware, especially, we have to be very careful and choose the values, right? Values for our data types. Sorry, values means the type for the variables. So we have to be very careful. If you don't do that, then we'll have a big problem. Just the driver won't work, even though your code looks pretty fine, but the fundamentals are ignored, actually, right? So what's the answer for this choice? The answer was unsigned character, right? So in this example, we are saying an unsigned char is the correct answer, right? So let's look into again the same reasoning. This time I am sure that you will really understand why or what it is actually, isn't it, basically? So let's look into right, the sketchpad once again. So this is our assignment 2, right? So this was our test 2. Yeah. So when you look into this and we start calculating, when you talk about 8-bit, so it's pretty simple now, right? When you talk about 8-bit of data, so you have an 8-bit microprocessor, as you know, or 8-bit microprocessor, right? Generally 8-bit microprocessor or the controller. Now you are interfacing with your drivers, and then you wanted to communicate in their control registers. You get the data on the data registers. You have a status, right? So that's more about low-level device driver programming. Okay. So quickly check. When you think about the types, that's the whole idea, right? When you think about the types for this, just a second. Yeah. So when you think about the types, what we are really looking at is, oops, just hold on. Yeah. It's an 8-bit. So we have to ignore the other possibilities about integer. Okay. So let's look into the 8-bit. So we have a character versus unsigned character. So when you have signed and unsigned characters, what do you choose? Again, people say, I have a character, and they say they declare a register variable to interface with your, say control register, right? So you can have some register 1, then you have some CTRL, reg1. So you can have this kind of programming constructs, variable choices, in your program, right? Is character a good thing? Is the question, right? Once again, as you know that when you talk about a character data type, the memory requirement is 1 byte, and 1 byte is, as you all know now, it has 8 bits, and 8 bits really correspond to maximum possible or minimum possible values generally when we write exactly, right? So remember, these are the 8-bit positions, right, basically. Now the question is, again, we have to take one as, least significant, and this is most significant bit, just a representation format. Okay, so this is least significant and most significant bit. Do you really want to know, do you really want to assign, in your controller register, one of the bit as a signed bit? The reality is no, because think about controller programming, right? What do? We want to send some commands to that controller, right? And then suppose the controller is capable of accepting 8 bits of input, right? It means that, yeah, it has 2 to the power 56 functions. Okay, so controller is a very powerful controller. It can take 256 functions, 8 bits of input. Okay, now if you have like that, then you pretty much know that this cannot be a signed bit, because the moment you want to send the data, it will say, oh, I got a 1 here, right? Now if you write 1 here, if it is a negative number, 1 is a negative number, right, for C programming. So you are really wasting and you are confusing the controllers, right? Because controller says, yeah, this is more like a reset function, right? When you say all 0 0 0, maybe pretty much like a reset, or then you do 0 0 0 0 1, then 0 0 2, and then 3. So many values you'll have. You can have a 256 command values for the controller, right? So essentially think about a programming where the programming requirements are different, because the hardwares, right? Hardwares don't understand negative numbers. Hardware say, I have a controller function, and then function 0 or a 1 or a 2 or a 3, 4 means so on and so forth. Think about a printer programming. So it's a printer, let's say 1. 1 means I want to take a photocopy. So really want to take a photocopy with the function 1. And then function 2 on a printer, you say, yeah, I want to do a scanning of the document. So I'm doing a scanning. And then the function 3, maybe I want to do a fax, right? So you want to send a fax. So you can have any functions for your embedded programs, right? When you're interfacing with your computer. So when you do a C programming, always remember that controllers, processors, they don't understand negative number for their input functions, okay? So invariably, character is ruled out. Yes, you can't have character for it, no. So only choice is, remember, in programming, we should have unsigned character for it. Right? So some of you are from the industry, are going to join industry, right? So there is a special type defs. I have not covered type defs, but this is a good example to explain. In the type defs world, we always write unsigned character as some sort of a U8. So you define a U8. U8 basically means it's an unsigned, and then the programming guidelines and coding guidelines for that company. Think about automotive industries. Think about a lot of these embedded environments. They will never allow you to use a fundamental data type. They say, no, you have to use the one that is governed by the programming, programming disciplines, programming guidelines of that company. So when you want to declare a register variable, you say, yes, I have a control, right, Q. So you declare like this, because by doing this, you are anyway, internally defining an unsigned character, right? So this is what we do. So again, this is a long answer for that original problem, right? Okay. So let's come back into the class, and the reason why we have the answer as P. So even though you don't have 256 functions for your controller or your processor in the microprocessor, right? You're never going to declare a programming construct in C saying that it's a signed value, right? Because it just doesn't serve the purpose. It will confuse the controller more than anything else, right? Okay. So the answer is unsigned character. Now here again, what is the focus? The focus is on the right choice for your programming variable for a lot of these programming designs, right? Code can be good, and if the variables are not good, program just won't work actually. Okay. So look into the third one. Now this is a very interesting question. Okay, which data type is most suitable to store the length of a string, right? So now as a programmer, and especially C programmer at this point of time, right, we have to be very careful about the return values. Okay, a lot of high-level programming languages, they just don't care. They don't bother about all these things, because high-level programming languages solve a very different problem. Okay, There the focus is on a very big picture, and they don't worry about wasting lot of stages. They don't worry about wasting lot of spaces, okay, lot of memory locations. But C is not like that. C is exactly what you want it to do. So C, we have to focus on memory. We have to focus on efficient memory utilization. With a very small piece of memory, we can do wonders. That's the whole idea, okay. So string length function, why I have chosen in this example, because I think every programmer in the world knows what is str length, string length, okay. There are a lot of casual programmers and serious programmers, but when you want the length, we want a string length, we use string length. Let's look into that. If you already know the answer, we will cover little more, okay. If you already know the answer, my promise is I'll explain something more about it. And if you don't know the answer, anyway, here we go, okay. So which data type is most suitable for storing the length of a string? Int, unsigned int, long, unsigned long. Answer is unsigned long. But if you already know the real logic behind it, then it's pretty good. But I will explain more than why the answer is unsigned long now at this point of time, okay. So let's go into the sketchpad and try to understand more, okay. Now I think it's easy for us to relate, it's easy for us to relate to. Let me duplicate it once, okay. So remember, it's a live class, so you have to always bear with me for some time, okay. And it's my promise to explain as much as I can. So fundamental question: length of a string, size of any object, right? Think about this kind of programming requirements. Length of something, right? String means, yeah, I'm looking at maybe something, or any object means any object, something. The fundamental question is, can the length be negative? Can the size be negative? So your only answer is it cannot be negative. So what do we rule out? We rule out all the signed versions of the choices, right? So it cannot be int, it cannot be long. And I told you, I think, when you write int or long, especially in the implementation of C language, right? When you say int and long, by default they are signed. So this is ruled out. So what we are left with? We are left with unsigned versions of int and unsigned long. Yeah. So for a lot of casual programmers, and which is true, not a bad deal actually, right? What do we say? We say int length equals to str length of whatever str I have, right? It can be str or it can be your str length of, say, hello Sanfoundry advanced C class, right? Okay. So because we are casual programmers, we know that the length of the string cannot be too long, right? It can be like 2 bytes, 10 bytes, 2000 bytes, 2000 bytes, 2 lakh bytes, 2 million bytes, right? So we pretty much satisfy the requirement with an integer data type. That's what is all casual programmer do in casual programming, right? Okay. But as I ruled out, that you cannot be, choosing an integral values which is assigned. So it cannot be an integral value, right? So what's our choice? Unsigned integer, right? That is one choice. I'm not saying that's the answer. That's one choice, okay. Look into other choice, unsigned long. So the answer is obvious now, okay. So can the length of a string be greater than the size of an integer, which is unsigned integer, which we did in a previous test number 2? It's a 4 gig. 4 gig is the maximum possible length for a integer storage, right? Because 32-bit. So yeah, for most of the programming situations, we don't, we will never overshoot this, and in some programming situations, we might overshoot, so we require this, okay. Think about the person who has written the string length function, right? So what is a string length function? str length, because this is not written by you, this is part of C library, as all of us know. It's a part of C library or libc, right? It's part of C library, libc. And libc has to satisfy the requirement for all kind of programmer. So if you're doing a simple program or a complex program or a very large program, string length should be able to have one unique return value, and that unique return value should be the answer. In our class, what we have seen just now is that unsigned long is the most possible answer. It's the best answer, because if string length returns unsigned long, we are pretty much a very large string, 2 to the power 63, no, 2 to the power 64 minus 1, right? Because it's a 2 to the power 64 minus 1 kind of a thing, right? Basically, there's the maximum possible value, and this is the length what you see here. Okay. Now, as I promised, some of you know the answer, and I have to explain you more about something interesting about it. Okay. So let's come back into the lab and try to see the man page of string length. When you come into the man page of string length, none of these answers will be visible. Okay, you will see none of these are true. What is true is what you see in the man page, and as I said, I'm going to explain further. Okay, so if I'm going to explain further, let's look into the man page, man of str length. Okay, so here you go, string length man page. What does it return? It returns size underscore t. Now this is a question, right? This is a $1 million question actually. What's a size underscore t? Is it a fundamental data type? No, not at all, because Cunningham DC have never defined size underscore t as a fundamental data type or a primitive data type. Okay, so size underscore t is basically a type def. Yep, it's a type def, right? Now when you say type def, you will see a type def, you can always search in a lot of header files. Okay, and it's easy to get and understand what the type def. So one of the type defs I'm going to write here is basically unsigned long, and say size underscore t. Because as a programmer, your focus is you are interested in size. You are not interested in long, integer, short, and all those things. You just want to declare a programming variable which is going to store a size of an object. And then size underscore t should be the choice, because you don't want to worry whether it's a 32-bit system or a 64-bit system or a 16-bit system, because your program needs to be portable, right? So the beauty of type def is it allows you to be a portable code. Okay, generally, right? That's the beauty actually. So I will cover type def in more detail in one of these classes. Okay, so I'll cover in this advanced class. I'm going to uncover all the secret. That's my promise. Okay, yeah. So size underscore t is the real answer, and as I told you, for the sake of this particular presentation tutorial video, right? You should assume that yes, this is a type def, which is correct. It's not as simple as that when you look into the error files, but eventually this will boil down to this value generally, right? Type def is very good. Size underscore t, depending on the platform, you can have a lot of type def for size underscore t. All right. So what's the summary here? Because as I told you, our goal was to understand. The summary here is when we think about designing a piece of software, our design is good, absolutely fine, but choice of programming variable constructs are very important. It may or may not, your program may or may not work if you have a wrong type. And I'm just talking about fundamental type at this point of time. I generally do a lot of interviews for senior programming, right? So I think I've interacted with so many people in the last 10 years. And everybody just understands string length function. They understand integer, character long, right? And then when I pose this question to them in an interview for very senior positions in a lot of the startups, 90% of the people get it wrong because they have never thought like a designer. Okay. So the purpose here once again is, data types are fundamental. Choose the right data type and your program will be rewarded. Okay. So I think that's the summary of this particular discussion, right? In terms of fundamental data type, and I hope that you have understood the crux of what I'm trying to convey here. Okay, so let's move on to non-fundamental data types, or what we call is user-defined data types. Okay, so when you talk about user-defined data types, you all know it's a standard set of Cunningham-Ritchie choices, right? Now, what is user defined data type? In your programming situation, you will never have you will never have a primitive data type satisfying all of your requirements. Okay, what you really require is to now represent a lot of real world programming examples, right? Think about an object, employee database. So you think about, I want to create an employee database. So shall I use integer or a character or a short or a long, right? They are fundamentals actually. Okay, so you require a different construct for that. So C language says, okay, if your programming requirements are not getting satisfied with primitive, just define your own. Go ahead and define your own types, and this is the beauty, right? And then eventually we choose some of these. So what is user defined data type? User defined data type is defined by the programmer. That's the crux. It allows you to define your own programming fundamental constructs for the compiler, right? So compiler says, okay, I'll give you that space. So what are those? Obviously many of you know that structures, and then unions, then enums, and then type types. Okay, I will have a great coverage on them in some of the other topics actually. Okay, also, right? So when you talk about the structure, it's fundamentally it's a collection of lot of data types that you have. It can be a user defined data type or your fundamental data types. It can be a pointer to something, right? So structure is a collection. So think about an employee database. Just to give you a small demo on this, right? It's just a small demo. Okay, so let me create my own scratchpad at this point. Okay, so this is the one, right, on the demo. So it's just a scratchpad. Okay, there's nothing about special about it. Yeah. So when you talk about this so employee database, so we're talking about struct employee DB, right? So that's employee database. Don't worry about the syntax at all at this point of time. My assumption is, you might know it actually. And again, this is a demo scratchpad. Some typing mistakes are inevitable. Okay, so you can say I have an integer which is like a employee number. Think about you want to use an integer or you want to use an unsigned here. Okay, because employee numbers generally are not negative unless there's a special meaning to your employee code, right? Okay, no problem. So you have an integer. So you have an integer, right? So I'm just making a proper typing thing. And what do you need? Require a name of an employee, right? Basically employee number, and then you have a character array and you say name, and then you define a name. Maximum possible name for an employee can be potentially this, right? So that's what it is. And then what do you want? Employee number for which department, right? So you'll have a department ID, for example, right, in different companies. So you will have a department ID in an employee. So you will say department ID. Again, think whether it can be negative number or positive number, right? Department ID, dep ID, department ID, right? That's a number. So what is happening now is you want to create a programming construct. You want to create an object which represents an employee, right? Basically. So what do? You say employee DB, and then you want to create the first employee record, right? So you say employee number. So not first employee record, you want to have a variable object for that. So you say, I have a variable object called employee, right? Employee. So this is the object or a variable. Compiler is going to allocate a space for this guy this much, right? And then that's where you are actually, isn't it? So that's as simple as that. So you can choose your structure, any structure for your programming requirement. Now we have unions. Unions are fundamentally different than a structure. They look like a structure, but they are not structure. Unions are a necessity in the programming language. You cannot retrofit a program and say, okay, I've written a structure, I want to convert into union. That is a very bad programming practice. No, you just can't do that. Union has been created for specific programming situations, and it cannot be retrofitted back into the program. If your program design requires a structure, yes, it has to be a structure. If your program requirement does not require a structure, it requires a union, it has to be a union. So you cannot retrofit saying that, okay, let me do a structure, later I will convert into union. No, that is just buggy code. It's a lot of issues. Okay. So when you talk about union, what is a union? By definition, it's basically again a collection of a lot of data types here, correct? Collection. So when you talk about union here, right? So when you talk about union, what happens is, yeah, you can say union. I will not use the word employee database because that is not the purpose here actually. Okay, so we'll say union, and then we can call it as maybe some u1 because I don't want to confuse people, right? So we have a union, say, called u1, and ignore that guy at this point here, right? Basically, oh, something got deleted, no problem. Yeah. So in this, again, it's a very abstract example, right? Because you say union. Let's consider for the time being, okay, this particular declaration, in terms of designing of the union type. So we have three different things here, right? I think maybe it's better to, it's good to remove it because this is not fitting in well actually, right, in union definition. So we will have integer called A, you have a character called B, and I think that's pretty much it at this point of time. Or let's take integer B, okay, we'll take integer B. So in a summary, if it is a union, the total memory allocated for this particular union will be the memory required for the biggest member or biggest field of this particular union. So what is the memory requirement for integer? 4 bytes. What is the memory requirement for integer? 4 bytes. So total memory requirement is still 4 bytes. Okay. So union, which is the biggest? 4. This is also 4. This is 4. So this is biggest. So total memory required for this union will be 4. Had it been a structure, the total memory requirement would have been 4 bytes for this and 4 bytes. So memory requirement would have been a 8 byte for a structure, right? So yeah, so you can see the fundamental difference, right? Okay, so remember that unions are different programming constructs and there is a requirement. I will cover with some live examples in the kernel code when I cover union. I'll give you some example about unions. Okay, at this point it's easy to remember that unions are used where you want to look at that piece of memory. Piece of memory is just 4 byte as in the previous example, right? You will see it is 4 byte here in the piece of example, right? So when you look into the memory, you are looking at one of those fields, one of those members, okay, at a time. That's it. So unions can be very useful if you're writing a protocol, if you're writing some protocol version 1 or version 2, version 3, version 4 of the protocols, right? You have headers for TCP, IP, headers for your some funky protocol for which you have written a hardware. Think about, Wi-Fi, think about we say, right, basically we have 3G, 4G, 5G technologies, right? So think about any protocols, and if your hardware, if your software, if your drivers are supporting all those versions of the protocol, most likely somewhere in the implementation you will encounter union, because once you get a packet out, once you get a packet or a piece of data, you want to know, oh, okay, is it which version? Is it version 1, version 2, or 3 or 4? And once you deduce that same piece of memory is represented as version 1 or a version 2 or a version 3 or a version 4, right? So it's just a choice. So it's a union actually, the implementation. So that's as simple. I'll still show you the real code in the kernel, when the time comes up, when you talk about union. Okay. So these are very important structures and unions because they define new objects based on your programming requirement. What about enums? Enumerations are simplifications, right? Basically, I will cover it. It's good for good programming code. Basically, we have a code where we can write enums for specific programming situations. It is more for code readability, right? It's good for code readability and maintainability. I think enum is a very good choice actually for that. Type defs I covered, and I'm going to cover in more detail about type defs later actually. Okay, so we'll cover it. So they are declared by structure, unions, enums, type def, keywords respectively. Isn't it? There is one more type which I have not covered so far. It is known as long. Okay. Now long is it a user defined data type? The answer is no. Is it a primitive data type? Yeah, you can say it's 50-50 actually. Okay. So some of you may or may not have heard of long. Okay. So what we can do is I'm going to just say, I'm just going to say I will write a program, right, basically. So we'll say long, okay, long.c. Okay, so let's quickly do a live code long.c, and pardon me for some of the mistakes in this live code if I have. Okay, now the objective here is first to tell you, some of you are not aware of long. That's the reason I'm doing this code. Okay, long is yeah, it's part of Cunningham-Ritchie definitely. Okay, but many people generally don't use it, are not aware of it. Long L, and then I say L equals to some hexadecimal number AA, BB, CC, DD, EE, FF. So how many we are there? So we have 1, 2, 3, 4, 5, 6. And then maybe 0, 0. Okay. I'm writing some number. Okay. So we will say value of L equals to percentage X. I am representing in hexadecimal notation. Okay. Since it's a long data type in hexadecimal, I think I have to use LX. We'll just compile it, and compiler will tell us whether we are right or wrong actually. Okay. So let me compile this code. So again, I have a problem. I think I have a small typing problem. Long L here. Okay. So we'll do we are defining the value here, long L. Okay. So what it says is that it's a long int. So I have to think about this, as you know. Okay. Yeah, it's an LL. It's a long. So now don't worry about some of these compilation, compilation warnings or errors actually. Okay. But it's good for you. Earlier in the 32-bit world of programming, compilers were lenient, but in 64-bit programming environment, compilers are very strict. They always throw you the errors and warnings, and then they really want you to do a good programming actually. Okay. So what you see now here is you are seeing that compilation is through, and then we have written. So it's a hexadecimal A, B, B, C, D, right? Actually speaking, you may not be able to understand immediately because this problem could have been solved using a long data type also, right? So if I choose one more called long, and it will say simply long, right? It is just a long, simply long, and I say simply long SL, and it's simply long, right? So we'll say value of SL is equal to simply long, and I have to remove this. Okay. Yeah. So we'll compile this. Compilation is through, and it's printing the same value. So what's the difference? Long on a 6, and now remember this is a 64-bit platform what I have. So if you say uname minus A, you get a data, right? This is basically Manish. This is Bajaj, my VirtualBox machine on an SMP Ubuntu 20, and then I have an x86 64-bit environment, right? So that's the environment on a 64-bit platform. I'm running a 64-bit platform. Okay. So on a 64-bit platform, long and long are just same. It's 64-bit and 64-bit. So long as a data type was created primarily for a 32-bit environment, because in 32-bit environment, if we have to write a C program for large data, what is the meaning of large data? The meaning of large data is our assignment number 1. 32-bit programming, right? We had obviously hard disks which are 100 GB, 200 GB. Hard disk partitions are very big. So if you remember the very first assignment on the hard disk partition, right? So yeah, partition can be like this. Can we store this value in integer data type? Integer data type? Answer is no, correct? So when you see this, why we needed a long? Okay, so I think the better approach is to duplicate the slide and then delete this. Okay, yeah. All right. So why do we need a long? Long was originated for 32-bit environment. So compiler, C compiler you can see that there was no compilation error, right? So C compiler understands it, understands. That's the beauty, right? C compiler understands it. So whether it's a 32-bit system or a compiler or a 64 compiler, compiler knows that there's a long, but the genesis was 32-bit environment, okay? And in 32-bit environment, what you see is you can still store 4 GB. That's what we discussed in the previous assignment, right? So we have 4 GB of information there, right? Now in the 32-bit environment, you can have hard disk which is 100 GB. You can have 200 gig, and then you have think about databases of terabytes of databases in 32-bit environment on a 32-bit systems, right? So you can have 300 terabytes. You have a humongous amount of requirements. So to satisfy that, C programming language had to devise a data type known as long. In the 32-bit world of programming, we had before long we had integer and we had long. But remember, on a 32-bit environment, integer is anyway 4 byte. So you are constrained with 4 GB of maximum value. Long was also 4 byte. Okay, there was no choice. There was no difference on a 32-bit environment. So if you declare a variable, one hard disk partition or a hard disk size in terms of bytes, it is just 4. So you don't have a choice. Okay, so it was really created. Long was created to solve the problem where you can have a long data. Okay, so this was 8 bytes. Sorry, it was 8 bytes. So you have 8 byte of information that you can store on a 32-bit environment with a long type. So if you compile the same code, if you have this code and if you want to compile it, right, if you compile this code on a 32-bit platform, then you will get a very different answer, right? So because you can store like this, but you cannot store like this. This will be a compilation problem on a 32-bit, because in a 32-bit this is 4 bytes. I do have a 32-bit system in place with me, okay, and I can surely give a demo for that. So let's do the lab for 32-bit system. Before I move to 32-bit, I'll just show you the hardware. So I have an x86 64-bit environment, which is a 64-bit system. On a 32-bit system, let's move there and just first confirm that it's a 32-bit. We do a uname minus machine. So it says i686 system. Okay, so in a Linux platform, if it is denoted as i686, 586, 386, 486, then it is primarily a 32-bit hardware. So the program that we had on the 64-bit environment, I have just taken it into this machine and I'm trying to compile it now. Okay, so let's compile. Here one of the problem is long will work. It's a true 4 plus 4 8 byte data type, but when we declare a long, simply long SL, and then when I try to do the assignment, this assignment operation, compiler will have issue in terms of a very large size. So it might say that it's an overflow condition, it's a really large size. Okay, it will not be able to store because on a 32-bit system the size of long is just 4 bytes and it is a very large value. So let's compile this code. Yep. So what we see here is we are seeing that we have a overflow condition in this case, right? We have an overflow condition. Integer constant is too large for a long type, right? But it's a warning. So in C language, even if you get a warning, you get your a.out. So if you run this a.out, you will see a different answer. You will see that the original value of L is exactly same as what we have seen, what we have typed in our program. But that long data type, simply long, you can see there is a great truncation because it's not able to store the upper bytes of that entire assignment. Somehow it is taking only one portion of it, right? Yeah, so the summary is on a 32-bit environment, long is meaningful and it really helps us for a 8 byte data storage capability. Long is only 4 byte. Whereas when you move back to 64-bit environment, in 64-bit, both long and long are same. So there is absolutely no necessity to declare any data type as long. So let's move forward and try to understand the next point in the topic about user defined data types. Okay. So having covered the primitive data type and long in that, and then a user defined data type, I have to move on to really come at collections, right? Or a specific thing, dependents, some pointers, some collections. So what are those? Basically, they are derived or dependent types in C programming. Okay. So when you see that, arrays. So when you talk about arrays, what does it mean? You want a collection. So you have an integer, you want an arrays of integer. You have a structure or a union, you want an arrays of that, right? It's a basic collection. So it is kind of derived and dependent both, right? Because we are deriving a collection out of a dependent type. So it must be some type. Array itself is not a type, it's a collection. Okay. So it is dependent on that. Same thing applies for PTR or pointers in C programming, because you want to do a pointing, right? You want to point. So you want to point to an integer, you want to point to a structure, you point to a linked list, you point to a tree or a B tree or RBL tree. So you require a pointer. And you want to point to a void, like a void pointer, as I talked about malloc. Okay. So you have a pointer pointing to something. And then you have a special situation known as a function pointer. So what's a function pointer? Ultimately, it's a pointer. It's storing the address of function to jump into, right? So it is going to jump into the function. Right? So remember, derived types are dependent on other types or derived from other types basically. Examples: array of chars, integers, structures, unions, pointer to char, pointer to integer, pointer to structure, PTR to PTR, and so forth, right? So I will have a huge number of discussions, huge amount of discussion for all of these in my live real life examples and in my video tutorial classes, right? Basically, so I'm kind of skipping it here right now. I'm not going to explain most of them because it will get covered in the slide. So as you know now, right? Basically, the primitive data type, user defined data type, and then dependent or derived data types are fundamental classifications against which we can do any kind of C programming. Okay, so I think this is just a summary about what I wanted to discuss about in summary, right? I wanted to discuss these three things. I hope you enjoyed this long discussion. Okay, and do write any comments that you have in the comment box below, because if you have comments or queries, I'm definitely going to answer it. I'm monitoring it daily, right? So I see people write comments and I reply to them. Thank you very much. See you in the next class. Thanks for watching the video. We have put important links in the description and the comment section below. If you really enjoyed our video, please press the like button below. We plan to release one video per week. So go ahead and subscribe to Sanfoundry by pressing the subscribe button below and turning on the notification bell.